Now we will be doing Station 6, Electrical Energy. We'll be doing 3 exercises, one with the battery and compass, and then another one with a hand-generated flashlight that we've used in the teacher's activity, and then 2 more with motors, one where we disassemble one and one where we use one. We'll be going through the Station 6 guide and going through all the parts and entering all our information on this paper right here, the Station 6 guide. So we're going to start with the first one, which is the battery and compass. So what this is to do is we're going to attach the battery to the holder, and then what we're going to do is set it up like they did in this diagram, where we're going to put the 2 wires into the metal pieces, put the battery inside, and then run the compass over it. So the procedures are to place the compass on the table and wait for the needle to stop moving. Okay, so I did that. We gotta wait for that to stop moving. As we do that, we're gonna hold a heavy gauge wire over the compass parallel to the compass needle. All right, now notice how the needle observes. Nothing happens, see? When I move this wire over here, nothing happens because we didn't do anything yet. We rotate the wire perpendicular to the compass and observed it. See, nothing's happening. All right, now what we're going to do is we're going to place the battery in there and set this up and then see what happens. We're going to repeat steps 2 and 3. So I'm going to set this up over here. I'm going to show you how I set it up right there. First thing you do is you take the battery, place the battery in there. You take this wire, which is a heavy gauge wire, and I'm going to hook the pieces inside. Oops, hooked it in there. Hooked it in there. The key here is that it is touching the metal piece on both sides. Okay, gotta get that spun around. This is a little difficult to do at times. Now we're in. All right, oops, sorry, too close. So it's hooked into that side, hooked into that side, and the wire goes over. So now we put the wire there. We have it run up. And we're gonna take our compass and run our compass over it. And notice what's going on with the compass needle. It changes, look at over here. You can see where it's showing north is. But when we move it over here, it changes. See? And what we could do is this says to move the wire over the compass, repeating steps 2 and 3. So if I put it down here and take my actual wire, which is hooked up to this right here. All right, I'm just gonna hold it and move it over the compass. Look what happens, it moves. Move it around. Before, nothing was happening. All right. The battery can become hot. Luckily, it's not coming hot yet. But what happens if I move the wire over the compass, or I switch this around, and now I move the compass over the wire. That's the first activity. Oh no, it was sideways the whole time. That doesn't matter. All right, now we're gonna move to activity 2, which is the flashlight. So we have our flashlight here, not lighting up, right? See, not lighting up, but if I shake it, get some light. Now exactly how does that happen? That's what you're trying to figure out. So no light until I shake it. Then you got a bunch of light. You can get that light right in there, see? So the activity here is activity 2, and it states, observe the hand-generated flashlight. Notice the magnets of coils in copper wire. Draw the hand-generated flashlight, labeling the magnets, wires, and copper. So, part 1, you were supposed to answer let's get this here. You're supposed to explain how the current affects the needle of the compass and describe the energy transformation. Part 2, with the hand-generated flashlight, we're going to draw and label the magnets, copper wire, and light bulb. All right, so that's just an activity. Here's what the flashlight looks like. You can see inside. There is the copper coil. And the magnet that moves up and down, you can see going right there. It's the silver thing. The silver thing passes back and forth every time you move it. And that's what's generating the electricity. All right, they also want you to label the light bulb, and obviously there's your light bulb. That is part 2. All right, part 3, we're going to deal with the magnet. So right here are 2 magnets. These are my energy transformations, so you don't necessarily need this. All right, so part 3, a very simple part. We're going to be going to look at the disassembled motor and draw and label the parts of the disassembled motor and label the magnets and wire. All right, so right here is your disassembled motor. Okay, so you're looking at it. You can look at it from this direction. Look at this one. Now then it says pull out the center section. So from this magnet, if you push on here, it's easy. And I can actually pull out the center section. Now the magnets inside here will make it a little difficult. See that? And then you got your center section right here, which has the copper on the inside, around the stator. And watch this, when I go click the back, it pulls back in, and it magnetizes itself back in. All right, so once again, there's your one piece of your motor. There's your second piece. All right. That's your take apart motor. So those pictures end up going right here. Draw and label the parts of the disassembled motor, label the magnets and wire. All right, and then pull the center section out, which we did, and draw and label the center of the motor. And record any observations. Now finally, we're going to compare a hand-generated flashlight and a motor, describe the similarities and differences, and then describe the energy transformation. Now we could do this with this motor. Now there's really nothing to answer about this motor, but this is the motor you have here. This says connected to a 9-volt battery with alligator clips. So we have our alligator clips here. That's what these things are called. All right, so I'm going to attach a green to one, and then the white to the other side. All right, and then this is my 9-volt battery. Whoop, where are you at, 9-volt battery? There you are. I'm going to attach one alligator clip to each top, one to that piece. And what do you think is going to happen? You can see that when I attach them, the motor's spinning. All right, now, what I can do is, notice right now, you can see it was spinning clockwise. If I switch my clips and put my white clip on the other side and my green clip on the other one, so I'm switching the way it goes, the motor is actually going to go backwards. And you can see that right there. So all I do is I switch the clips around on the bottom, and now my motor goes backwards. But this battery is able to move it nice and easily, and that is procedure 8 and 9. All right, finally what you can do is I can take this, and if I connect the D battery to it, this is my D battery, the big battery we used before. Notice what happens. So this is a little trickier. You have to put the white on one side and the green on the other side. But as you can see, it's moving just a little bit. It's trying to go, but it can't move. It's just moving a tad. There's not enough power in this battery to move this motor. All right, so that's comparing the differences and then the energy transformations. as you guys know, are right here. Here's the different ones in case you need it. Your goal now is to fill this out. This asks the couple of questions, sets of questions, and you draw your 3 pictures. All right, so if you want to go more in depth, you can read the Station 6, what's happening, and go into what batteries and compasses entail, how the motors and batteries work in conjunction with each other, as well as motors and generators. And that even gets you into the energy transformation in coal power plants. So once again, this was lesson 6 of the energy, final one. You guys did a great job.